My dear students, today I am going to discuss science for class 10. So some problems from the chapter of electricity. Now look at this diagram. Now some resistors are connected in this way. This is 2 ohm, 2 ohm, 2 ohm, 2 ohm. This is 10 ohm, this is 4 ohm, 4 ohm, 4 ohm, 4 ohm. Now this is the entry point of current which is positive, and this is the exit point of current which is negative. Alright. Now the question is, you have to find the equivalent resistance between A and B. So between A and B, what is the equivalent resistance? So that is what you have been asked to find. Alright. Now this diagram we must simplify before we go to find the equivalent resistance, because there are several circuits involved here. Alright. Now how will you simplify? Look at these two. So these two and these two, they are in series. So this 2 ohm and this 2 ohm, they are in series. So this 2 and this 2, they are in series because they are after one another. Now two resistors are connected in series if their terminals are different. But if their terminals are same, that will be in parallel. Now this 2 and 2, 2 plus 2, 4. This 4 and this 2, they are connected in parallel because their endpoints are, their terminals are same. This is A is the terminal and here this is the terminal, right? So this one is connected, this 2. So this 2 ohm resistance is connected in parallel to this 2 plus 2, 4, right? So this 2 series and with them these 2 parallel, okay? Now come to this 2. So this thing, so this diagram is referring to this part, alright. Now with this part, this 2 ohm is in series. You see this and this 2, they are in series. So from here we draw 2 ohm, that is in series. So now 1, 2, all the 4 resistors are taken care of. So these 2 are in series, with them these 2 in parallel, and with this group, this last 2 in series, alright. Now with this group, so this is the diagram of, so I have shown there this part. So these 4 resistors, so this enclosed part, you see that is redrawn as this, okay. Now with this 10 ohm is in parallel. So this 10 ohm is parallel to this part. Suppose you call this whole thing R1, then R1 and 10, they are in parallel because you say their endpoints are same. This is the A and B are endpoints. A and B are endpoints of this part and this part. So their terminals are same, so they are in parallel. Okay. So this one and this one are in parallel. So this point is A and this point is B. So A and B, they are the terminals of this part and this 10, so they are in parallel. Now similar diagram will be for the lower part. So exactly similar diagram will be this way for the lower part. So this is 4, this is 4, so they are in series. This 4 and this 4, they are in series. Now with them this 4 is parallel, alright. So this is in series, then with them this 4 in parallel, this 4. So this 4 is parallel with this. So there is 2 and 2 series, and then these 2 with them parallel, that is 4 and 4 in series. And then with this 4 plus 4, 8, this 4 is in parallel, okay. Then this 4 is in series with this group. So this is another group, suppose. So this whole thing, you see, So 4, 4 in series. Then with them this 4 in parallel. And with this group, this 4 is in series. So this 4 is in series. This 4. So just like this. Okay. Now with this group, this bounded by yellow line, you see. So this bounded by yellow line, this part and this 10, they are all in parallel. So this group is parallel to this. So this one. Okay. So this is the simplified diagram. So 4, 4, 4, 4 series, then with them this 4 parallel, then with this group, this 4 in series. So similar to the diagram above. Okay. Now all the registers have been taken care of. Now you see this part and this part and this part. So we have got 3 parallel circuits. So this is, and this one and this one. Now, yeah, so you see now this one. So first let us calculate this part. First let us calculate this part. So how will you calculate this part? This 2 plus 2, 4. 4 and 2 are in parallel. So suppose we call this this equivalent resistance R1. So what is R1? R1 equal to 1 by R1. So what is 1 by R1? If this part we call R1, then 1 by R1 is equal to what? 1 by 4 plus 1 by 2. 1 by 4 plus 1 by 2. This 2 plus 2, 4, because they are in series. So this is 4, this is 2 in parallel. So 1 by 4 plus 1 by 2, that means you will get 3 by 4. Therefore, what is R1? R1 equal to 4 by 3. So this part, so R1 equal to what? 4 by 3. So this part equivalent resistance is 4 by 3. Now with 4 by 3, these 2 in parallel. So let us call, suppose we call that R2. So this whole thing, suppose we call R2. So this is R2. So what will be R2? So R1 this, and what will be R2? R2 will be this R1 plus 2. That means 4 by 3 plus 2. That is 10 by 3 ohm. So this R2 is what? 10 by 3. So R2 means this whole part. 1, 2, 3, 4. These 4 resistors together is 10 by 3. Okay. Now similarly, let us calculate this part. Let us calculate now this part. This part. So how will you calculate? Suppose we call it R1, R2, R3. Suppose we call it R3. So let us see what is R3 equal to. So R3 equal to what? 1 by R3, that is equal to 4 plus 4, 8. So 1 by 8 plus 1 by 4. So 1 by 8 plus 1 by 4. That means 8, 3 by 8, 3 by 8. So this R3 is 3 by 8. So R3 is this. Combination of these 3 is 3 by 8. Now let us calculate the whole thing. Let us calculate this. So 1, 2, 3, 4, the group of these 4. So let us call it, suppose R4. So this is R4, suppose. So what is R4 will be equal to? So this and this 4. So this group and this 4 in series. That means this plus 4. So 3 by 8. So that is R4. What is R4 equal to? 3 by 8. 3 by 8 plus 4. Alright? 3 by 8. 3 by 8, 1 by R, 1 minute. So 1 by R3 is 3 by 8. So therefore R3 will be 8 by 3. R3 will be 8 by 3. 8 by 3. So this R3 will be 8 by 3. 8 by 3 ohm. Okay. So this group is what? This yellow line. So this group is 8 by 3. Now this whole thing enclosed by green line, that is R4. So R4 will be this plus 4 because in series, isn't it? So R4. So what will be R4? This R3, 8 by 3, 8 by 3, this 8 by 3 plus 4, plus 4. That means 20 by 3, 20 by 3 ohm, 20 by 3 ohm, that is this whole group. So above 10, this whole upper part is 10 by 3, and below 10, this whole group is what? 8 by 3. Now this 10 by 3, 8 by 3 and 10, they are in parallel. So now let us call it, suppose, so R4 equal to 20 by 3. So this is 20 by 3 ohm. Okay. Now let us calculate the whole thing. So this and 10, they are in parallel. All right. Yes. Now suppose we call the whole thing R, simply R. So 1 by R equal to, yes, this 3 in parallel. This one 10 and this one in parallel. So 1 by R2, that means 3 by 10, 3 by 10 plus this 10, 1 by 10 plus this is 20 by, this is what? 3 by 10, 3 by 20, 3 by 20. Using the formula 1 by R equal to 1 by R1 plus 1 by R2, those formula you know. So this is 20, 20, so you get 2, 3, 6, 6 plus 2 plus 3, all right. That means 11 by 3. So what do you get? Equal to 11 by 3, 11 by, sorry, 20, 11 by 20. So 1 by R equal to 1 by R equal to 11 by 20. So therefore R equal to, so therefore finally we will come to the equivalent resistance between A and B. So therefore this is the final answer. R is equal to what? 20 by 11 ohm. So that is equal to 1 point something. So whatever it is. So this is the answer. So 1 point something it will be. Okay. So this is how you got this. So the given diagram must be simplified. Without simplification, it will be difficult to see. So simplify properly, then you will get the clear picture. And then use the formula, and finally we get the equivalent resistance between A and B. Between A and B, that means for the whole group, what is the equivalent resistance? 20 by 11 ohm. So 20 by 11 will be 1 point something. All right. All right. So this is about electricity. Now next one also from electricity chapter. Okay. Next question also from electricity. Now this is about power. This is about power, that is rate of consumption of electricity. All right. Now you see, when you go to buy a bulb or any electrical device, so there is some rating written there, rating. Now suppose you go to buy a bulb on which it is written 220 volt 40 watt. So you go to buy a bulb and on the bulb you see written this rating 220 volt 40 watt. So what does it mean? It means if you connect the bulb to a source of 220 volt, which is our supply means, the electricity supplied by the electricity boards is between 220 to 240 volt. Suppose you connect the bulb to this 220 volt, then its power will be 40 watt. All right. But this power 40 watt is not permanent. It is not a permanent quality of the bulb. All right. If you reduce the voltage, this 220, if you reduce, then this will be reduced. So this power 40 watt power is applicable only when the potential the voltage of the source is 220. Okay. All right. So that is the meaning. Now the question is, when voltage is halved. So when voltage is halved, so what happens to power? So power equal to what? That is the question. So the power of the bulb is 40 watt if it is connected to a source of 220 volt. But if you connect the bulb to a source of voltage is half, that means 110 volt. When voltage is half, that means 110 volt. If you connect the bulb to 110 volt, then what will be its power? It will be definitely less than 40 because you have reduced the voltage, therefore power will be reduced. But what will it be? So this is halved. So will this be half? That means will it be 20? Will it be 20? It will not be 20. It will be 10. It will be 10 watt. So this is halved. So voltage is, we have connected it now to 110 volt. But the power will be 1/4, 10, not half, not 20. Now how it is 10? See, that is what we have to explain. Okay, for explanation, we will use the formula of power. So this is the formula of power. So P equal to V square by R. Now there are some different forms of power. Power equal to V into I. Power is V into I square into R, and V square by R. So we will use this formula, P equal to V square by R. So where V is the voltage, R is the resistance of the bulb. Now resistance is a permanent quality, all right. Okay, now P equal to V square by R. So now this P is 40. Now V is what? 220. So 220 square by R. R is the suppose resistance of the bulb. We do not know the resistance, so we keep it as R. So resistance is a permanent quality of the device. Okay. So this is, suppose we call it number 1. All right. Now in the next potential, this power is what? Potential difference is halved. So next we have to find out power. So this power we have to find out. So V square. Now next V is what? 110. So potential difference V is halved. Voltage is halved. It means 110 square. So V is 110 square. Then R remains same. So this is number 2. So this was when potential difference is 220, voltage is 220, and this is when potential difference or voltage is 110, right? Now we have to calculate this P. What is the power, right? So what we do, let us now divide. So dividing 1 by 2, dividing 1 by 2. So divide equation 1 by equation 2. When you divide, what you get? 40 by P. 40 by P equal to, so when you divide this R cancel, so what you get? 220 square, that means 220 into 220 by 110 square, that means 110 into 110. So we are dividing 1 by 2. We get 40 by P equal to, when you divide R cancel, this by this. Okay. Now 0 0 cancel, 0 0 cancel, so 11, this 2, 11, this 2. So what do you get? You see 11 2, 11 2. 1 minute, 1 minute. So 2 to 4, 2 to the 4. Okay. So 40 by P is 4. So therefore, what will be P? P will be 40 by 4. So 40 by P is 4. So what will be P? P will be 40 by 4. That means 10, you see. So 10 watt. So you see this 10 watt. So when potential difference is halved, so power of the bulb will not be halved, will not become 20. It will be 1/4. It will be 1/4. Why 1/4? Because half square is 1 by 4, you see. Potential difference is halved, 1 by 2. But power will be, yes, power will be 1/4. Half square is 1/4. Why? Because you see, this is a formula square. Okay. So finally answer you get, yeah, this power of the bulb becomes not half of 40, but 1/4 of 40. That means 10. And this is how we can explain using the formula, this P equal to V square by R. Okay. All right. So this is the, yes. Now the third question, the third problem is from light, from the chapter of light. So all this is for class 10. So from the chapter of light, let us see this third question. The problem is how to make a lens of zero power. How to make a lens of zero power? That is a question. How to make a lens of zero power? All right. Now there are different ways. So the first way is this one. So number one method is this. By combination of lenses. So this using this formula, power is P1 plus P2. So when two lenses of power P1 and P2 are combined, so their total power will be P1 plus P2. This is the formula, right? Now suppose we take one lens with power suppose plus n diopter. Now you know D is the SI unit of power. Suppose the first lens we take with positive plus n diopter, and the second lens we take suppose minus n diopter. Suppose we take two lenses, one lens plus n diopter. Now plus means it will be what? It will be converging, that is convex. Suppose this one, this lens, converging lens, all right. So this power is suppose plus n diopter. And next one we take a concave lens, a concave diverging lens, concave lens of negative power. Concave lens has power negative, convex lens has power positive power, then concave negative. So we take same power n but opposite. So this is the second one. So this one is the first lens, this convex, and this one is the second lens, concave. So power of this one is plus n and power of this one is minus n. Plus n diopter, minus n diopter, all right. Now this combination of one converging lens and the other diverging lens. So combination of this lens will have a power of what? P1 plus P2, that means sum of these two, plus n plus minus n. That means it will be 0 because plus n and minus n cancel. So what is the power? 0 diopter. So this is how you can make a combination of two lenses, one converging, other diverging, both having the same power n. So here it may mean plus 2 minus 2 or plus 4 minus 4 or plus 1.5 minus 1.5, but sign will be opposite obviously. So therefore the resulting power will be 0. So this is how you can make a combination of lens. Now this is not a single lens. This is a combination of lens, but it behaves as a single lens. It is neither converging nor diverging because power is 0. Okay. So we can get a power of a combination of lens. But suppose we do not want combination, we want a single lens. Then what we have to do? So this is the second method. So the second method is this way. Now you see, this is the formula for power. So power equal to 1 by F. So in that chapter you have come across this formula for power equal to 1 by F. Now therefore F equal to 1 by P. Therefore focal length, power equal to 1 by focal length. Therefore focal length equal to 1 by P. Now if we want to have a 0 power, suppose P 0, then what will be F? 1 by 0. Now 1 by 0 is what? Infinity. So if we want to make a lens of power 0, P0, therefore that lens should have focal length what? Infinity. That means infinitely large. All right. Now suppose this is a lens. Say this is a lens. Now this is a curvature. This is a curvature. Now they have definite focal length which is not 0. Now suppose you decrease the curvature. When you decrease the curvature, focal length increases. When you decrease the curvature, focal length increases. So when you go on decreasing the curvature, so focal length will go on decreasing, and finally this lens will become like this. So the lens will become like this, you see. So there will be no more curvature. Now when there is no more curvature, that means focal length is infinitely large, because if you go on decreasing the curvature, what increases? Focal length increases. Now we have decreased the curvature such that it becomes plane, it becomes straight. Therefore, focal length is at infinity. Now, when focal length is at infinity, obviously power is 1 by, see now this lens, focal length infinity. Therefore, what is power? 1 by focal length. That means 1 by infinity. Now, 1 by infinity is 0. So 1 by infinity is 0. So power is 0. So this lens has power 0. So it becomes a plano lens. This kind of lens is called plano lens. Plano. Because you see this surface is plane. This is a plano lens. Or you can compare it as just glass pane, ordinary glass pane in your doors and windows. Ordinary glass pane, you see, like this, isn't it? This side surface straight. So this lens will have what? Power 0. So you can call it plano lens, or you can call it just a glass pane. All right. So this is how we can make a, okay, this is a single lens. This is a combination, but this is a single lens of 0 power. All right. Okay, now there is still another way. There is still another way, which is by using lens maker's formula. So this is a lens maker's formula. So power equal to refractive index minus 1 into 1 by R1 minus 1 by R2. This is called lens maker's formula. Now, power of a lens is equal to refractive index of the material of the lens, whether it is glass or plastic, minus 1 by R1 minus 1 by R2. R1 and R2 are this what you call radius of curvature of the two surfaces. So R1 is the radius of curvature of this surface, and R2 is the radius of curvature of this surface. All right, it may be this convex also, like this. So R1 is the radius of curvature of this surface, and R2 radius of curvature of this surface. All right. So this is the lens maker's formula. Now, if we want to have 0 power, see, power 0. Now 0 is a product of these two factors. Now this cannot be 0. Refractive index minus 1 can never be 0, whatever be the material. Since this is not 0, this part will be 0. That means 1 by R1 minus 1 by R2. This is 0. This is not 0. If P has to be 0, then this will be 0, because this is not 0. This cannot be 0. So from here what we get? 1 by R1 equal to 1 by R2. That means finally what we get? R1 equal to R2. So this is the condition. So that in order to give the lens a 0 power, what must we do? We must choose a lens so that the two refracting surfaces, so that the two surfaces have same radius of curvature. This surface and this surface, both the refracting surface have what? Radius of curvature equal. All right. Now this is how actually this what you call sunglasses are made. Now in the curvature of the sunglass, these two surfaces have same radius of curvature. So this surface has radius of curvature R1, this surface has radius of curvature R2, and they are equal. They are equal. So this is how the lens makers make sunglasses using this formula. All right. Now this formula is not included in the syllabus of class 10. So for syllabus of class 10, you can take that first and second method that we discussed. But this is also applicable, right, in order to obtain a lens of 0 power. So we have to make the lens so that the two surfaces have same radius of curvature. Is it clear? Okay, that is all for today. Okay, I hope this has been beneficial to you. Okay, for today.